What's up, everybody? Today we have an amazing problem for you guys, right? So let's quickly go ahead and read the problem statement, guys. So this is a very good problem, guys, right? So it says time-based key value store, right? So, but just by the name itself, right, it just sounds like a good one. So it says design a time-based key value data structure, right, that can store multiple values for the same key, okay, at different timestamps and retrieve the key's value at a certain timestamp. Okay, very interesting, right? So off the bat, they're telling us exactly what they want us to do, right? So we'll be doing some kind of key value data structure, right? Which you can kind of think of a hash map, right? So the key can have multiple values, right? So with for the same, right, there can be multiple values for the same key, but there's going to be different timestamps, right? So this tells us that we're going to kind of need also the key will be mapped to to a list of values, or potential values, right? So it seems that those values are also going to have some kind of a stamp associated with them, right? So it's very good to know. Okay, it says to implement the time map class, right? Okay, initialize the object of the data structure, that's the constructor, right? And the set function should store the key, right, with the value that's passed in as well, right? And a particular timestamp, right? So we're kind of following what they're saying, guys, right? Yeah, makes sense. And then it says so we store the key and then the value, right? And we also have to store the value at that particular timestamp, right? That's what they're saying right there. We'll go through a couple of examples. We'll solidify exactly what they want us to do, right? So it says the get function, right, will be passing in a key and also a timestamp, right? And we need to return the value that's the value, right? So we need the key, right? And then we need to find in the list of values that we have, right? We need to find the timestamp, the largest timestamp that's smaller than or equal to the timestamp that's passed in, guys, right? So we need to find that uh, timestamp and then return the value at that timestamp, right? That's what they're saying. I'd say there are multiple values, right? Return the largest timestamp param, right? So that's pretty much what I just explained, right? They want the largest, smallest value that's small, equal or smaller than the timestamp that's passed in, guys. Hopefully you guys are able to understand that, right? So let's go through the examples that I have here, right? So examples are very interesting. So they initialize it, right? And then they call set on the time map class. We pass in a foo. This is the key, right? And then the map, the bar at timestamp one, right? So that's the bar is the value, right? And the timestamp is also passed in, right? Which is the timestamp one, right? So we store that in our data structure, right? And then now they call get, right? They pass in a key and then also pass in a timestamp, right? And we should return, guys, right? Because in our data structure, right, we said that we stored at key foo, right? Key foo timestamp one, right? We stored the value bar, guys, right? You know what I'm saying? So that's what we have here. So we return bar when get called because one, guys, right? Is the largest value that's smaller than or equal to one, right? So we return it automatically, right? So we did call get foo, right? We did pass in the key, right? Foo, and they pass in also the timestamp three, right? You might be saying, oh, there's no three in there, right? But remember, they said that they want us to return the largest value that's smaller than or equal to the timestamp passed in, right? So the largest one is going to be the only one in there, right? Which is the number one as well, right? So we return the value at timestamp one, guys, right? Because we set that in our data structure, and then um yeah, that's the kind of what they went here, the examples they went here, and then we call set again, right? We store that value foo and we started that at timestamp four, right? And now we have the value of bar two, and then once we call get on foo at timestamp four, right, we have that exact thing right there, right? So we're good. And then that's good. And then that's for return bar two. We return the value at timestamp four, and then we call foo with timestamp five, right? We return the one that we stored at timestamp four because that's the largest value that's smaller than or equal to the timestamp passed in, right? So that's what we have here, guys, right? So hopefully you guys are able to follow, like, the thought process so far, guys, right? So let's go through to my drawing board, right, and kind of kind of talk about how we can approach this problem, guys, right? Um, so we know that we need to implement some kind of hash map there, struct key value, right? So for the key, we're gonna be given a key, right? So and we for the value we said it's gonna be a list of stuff, right? So we've kind of already talked about the data structure that we're gonna use, guys. We said we're gonna be using hash map to implement that, right? And we said that um the so for the key we're gonna have the key that's given to us, right? So let's say for this example, foo, right? We put foo, and then foo will be mapping to a list of so we need to find a way to package those two pieces of data, right? Because there can be many different values because there's gonna be many different timestamps, right? Because we need to a way to efficiently um, account for each one of the different timestamps that may happen, right? So what we're gonna have to do, we could easily for each value timestamp with the value, right? We could create our own custom data structure, right? Or we could just use a pair guide, right, to just package those two data up, right? It's up to you how you want to do that, right? So in the code, I'll be using a pair data structure to just hold the two pieces of data, right? So so now when they call set on this, right? So we get foo maps to a list, right? And then in our list, right, we'll be adding the timestamp, right? So one, just timestamp, and also we're gonna call bar, right? Right. So now, and then every time they call set, right, we just add it to we we just get the corresponding list, right, with the key that's given to us, right? We get the corresponding list, and then we just add that new entry to our list, right? That's how we're gonna keep track of all of the different timestamp for all of the different keys, right? By using this kind of approach, right? So we have the key mapping to a list of pairs, their structure, which is holding the timestamp and the value at that particular timestamp, right? So I just want to clarify that, make sure you guys understand that, right? Okay, so the set function is taken care of, right? So now the get function is where we're gonna have some kind of interesting thing that we're going to do, right? So, but let's go through continuous example, right? So when they call get foo1, right? We have this in our data structure, right? So we can easily just return that timestamp one, right? And just return bar for that value, right? But let's say there's other timestamps in there. How do we know to return the largest smaller number, uh, the largest smaller number, and then or equal the largest number smaller than or equal to the given timestamp, right? There's gonna be a little more work to be done, right? So for the first example, we return that, that's easy, right? Okay. So now let's say we start adding more stuff, right? So for 3, we return will be this as well, right? So now let's say we start adding other stuff, right? Say we go to this example, right? We start adding timestamp 4, and the value is bar 2, right? Okay. So there's a couple ways we could do that, right? So now let's say they're asking for foo 5, right? And the obvious way will be to just do a linear scan to find that timestamp that's the largest timestamp that's smaller than or equal smaller than or equal to that given timestamp that's best in, right? That's gonna be a linear time, guys, and our list can be extremely huge for a particular key, right? So we want to do that, right? So the linear scan will be good, right? So what other ways can we do it, right? You know what I'm saying? How can we efficiently search for that particular value that fits that constraint that they're asking, right? That's kind of a little bit of thinking that we're gonna do. So let's go back and make sure that we read the whole problem, guys. Make sure that we're good. Okay, looks good. Okay, length, it looks good. But we see that they're mentioning here, guys, right? All the timestamp, right, will be given to us in a strictly increasing, right? So this is a very good news that they're telling us, guys, right? They're telling us that our list is gonna be sorted, right? We're not gonna have those weird thing, right? Let's say for this particular list, right? We're not gonna have a timestamp. So we added 4, right? We're not gonna have timestamp 2 added like that, guy. It's not gonna work, right? We don't have to worry about those kind of scenarios because they've said it's not gonna happen. It's gonna be strictly increasing. So we're guaranteed that those things will be in sorted order, guys, right? in good shape, right? So the next one will probably be 5 or 6, doesn't matter. In board 3, it's not gonna matter. I'm saying. So so we know that it's gonna be strictly increasing, which is the good part. So that's exactly what we're gonna do, guys, right? So since it is sorted, right, we could leverage binary search to efficiently search our list, right, for that value that we're looking for, which is the largest value smaller than or equal to that timestamp, right? So this is exactly what we're gonna do, guys, right? So apply binary search to find that value. So hopefully you guys are able to understand, right? So we're still gonna have, guys, we agreed on a map. In our map, we're gonna have a string, right? And also we're gonna be giving a list of here, right? And we're gonna have integer on the string. Okay, like that. Map, new hash map. Okay. So we initialize it right there, and then now we're gonna do our check here, guys. So in our set function, if our map does not contain, guys, right? Does not contain that particular key that's passed in, right? We're gonna initialize memory for it, right? Put the key on a new array list. Okay. All right, and then after we do that, we could easily just retrieve that list, right? So get that key and then add a new entry for the thing, right? So it'll be timestamp, and then we're gonna pass in the value, right? So okay, it looks good so far. So our set function is pretty solid. Looks pretty good, right? And then now our get function, this is where we're gonna have a little bit of work. What we're gonna have to do, we're gonna have to check, guys, right? Map contains a key. So if it doesn't contain the key, right? If we don't have that key, right? It's a bad case. We don't want that, right? So we're gonna return an empty string, right? And then this is where we apply the binary search to find the largest values smaller than or equal to the value, right? So before we do that, let's re let's retrieve that from that list from the thing, right? From the map, right? So map that gets key, right? So get me that list, right? Because that's the value that I'm getting right there, okay? And then we're just gonna do list that size -1, right? So this is our initial search space, okay? We're gonna be applying binary search, guys, right, to find that value, okay? Less than the right, we're gonna have our mid, we're gonna calculate that. Right minus left plus right divided by 2, okay? Okay, so we got our midpoint, and then we're gonna make decision checks, right, to know in which partition to search and to cut out, right? So our initial thing, we're gonna do list that get key, right? No, list that get on mid, get the key, right? Right, get the key. If that's equal to the timestamped passed in, right? You can easily return that. Return the value at that at the midpoint, right? So we just return that. We are in good shape, okay? So now if that's not equal to the timestamp, so what we're gonna do, we're gonna make some decision checks right here, okay? To know when we should go left or right. So if the key, right, is less than the timestamp at this particular at the midpoint, right, is less than the timestamp, right? If it's less than the timestamp, then I go right, okay? I'm trying to find large right, and then now I keep going right, and then now if it is greater than the timestamp, right? So this is greater than the timestamp, then I know I should go to the left, okay? And then after we do that, right, we're gonna do some post processing. So what we're gonna do, If the right corner right is less than 0, then we didn't find the largest number. We didn't find any number that was smaller than that particular timestamp, right? So which is bad. We gotta return an empty string. And then after that, guys, I think we made all the checks possible. So we're gonna let that get right, that get value, right? Okay, so looks good so far. All right, so this video is long enough. All right, sounds good. So we've talked about we use a map, which is has a key, maps to a list, and then we initialize that, and then we stored our data right there. If we don't have the key in the map yet, we create entry for it, and then we add the pair, right, the timestamp with its value, right, and then to find the largest value that's smaller than or equal to the timestamp that's passed in, right, we apply boundary search to find that, right, by cutting down the search space every time, and then yeah, press submit, guys. See if we pass all the test cases. Awesome, guys. We were able to pass all the test cases, guys. So if you guys found value, about watching this video, make sure to let me know in the comment section, guys. We really appreciate some kind of feedback. You know what I'm saying? So I want to say thank you guys for watching again, and I'll see you guys in the next video.